Hey, Mr. Boy Ted here again. So, local winds versus global winds are kind of what they sound like. Local winds are right here, like here in Orange Park, Florida. Right here. Global winds are big winds. Winds that take place across the whole planet. Like if you look here, we have things that come from the east, which we call easterlies, and things that come from the west, which we call westerlies. And all of these little tape lines include our lines of latitude. The equator isn't taped off, but it's called the doldrum. So this probably looks pretty intimidating, but we're going to break it down to make it a lot simpler seeming. Both local winds and global winds are caused by the unequal heating of the earth, just like we saw in class with the hot plate and just the open air from the room. So local winds, you might have a hot plate being the sun heating up the beach and the water. And since the beach during the day is hotter than the water, the sand burns your feet but the water doesn't, the wind blows from the beach to the shore, blows towards the hot plate, just like our little contraption that I'm actually using right now to hold up this iPad showed in class. This blew towards the hot plate. Now, if you are at the beach at nighttime, you might notice that the wind blows towards your back. It blows towards the water because the water is warmer in the nighttime, so it blows towards warm. Globally, it follows the same trend. It's blowing towards the warmer equator. So these arrows are going towards the equator, and these arrows at the poles are going towards the equator. The only exception to air going towards the equator with these currents are these westerlies. These westerlies because they're from the west, so they're labeled with a W. These westerlies blow from the west. Oop, you can't see that one. They blow from the west up towards the poles. So you don't have to have this map memorized before you panic. But you do have to kind of understand why the map is the way it is. So I think we might have to break it down a little bit to understand why they point the way they do. And we might need a little music. Here we go. Check it. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. Y'all know that. Westerlies blow from the west towards the poles. The white snow cap easterlies, they blow from the east towards the equator. I'm out. Whee-wee, if that wasn't some good music. So, if you look at this map that is on the back of the room, so you'll see it in class tomorrow. If you look at this map, you'll notice the lines of latitude. There are two names for the ones that we're going to learn. There's the one right on the equator, and we call that the doldrums. The other ones we'll learn about are at 30 degrees north and south latitude, and these are called the horse latitudes. So the doldrums are right on the equator, and the horse latitudes are at 30 degrees north and south. The doldrums, just like you see on your map, are just the areas where the sunlight is most intense, and that's where Air is expanding and rising just like it did over the hot plate in our class. So cooler air from higher and lower latitudes, places further away from the equator, is rushing in to fill it just like we had happen in our class. This is really the left side of the convection current shown. So this is the part where the hot air is rising. To look at the part where the cold air sinks, we have to look at those horse latitudes again. Now it's hard to imagine a three-dimensional version of this, so I'm going to show you with some arrows. So hopefully this can give you an idea of what's going on. At the doldrums, the equator there, doldrums, we see the hot air rising. And as it moves northward, Coriolis makes this thing turn the way it does. But as it gets cooler and sinks down, it sinks down at these horse latitudes. So the horse latitudes are really latitudes of sinking air. And as they sink, the air expands out as they hit the ground, spreading out, creating these dry areas across the globe because they lost all their moisture in the rising process. To recap, global winds occur across the whole globe, but local winds only occur in a particular area. All winds are caused by pressure differences, usually caused by differences in temperature. Westerlies blow from the west, easterlies blow from the east. The doldrums are another name for the equator. The horse latitudes are 30 degrees north and south. Air masses rise at the equator, and they fall at 30 degrees north and south at the horse latitudes. The air masses rise and fall because they're part of a convection cell, the same kind we learned about in the mantle, but this time with air in the atmosphere.